All right, guys, today we are going to, your short one, thank you. We're going to relax? No, sorry. No, today we're going to kind of look at all three of our methods because when's our test? Tomorrow. It's Friday. I think I've asked you guys every day this week. All right, your test is Friday. So we're looking at kind of all three of our methods because on your test, it's kind of broken up into 4 different parts. There's going to be a section that says to solve by factoring, so you must factor. A section that says solve by using the square root method. You must use the square root method. A section that says solve by quadratic formula. You must use the quadratic formula, right? And then the last page is where this today will help you with, where I will give you like 6 problems, and I say use each method twice. So you have to pick 2 of them to factor, 2 of them quadratic formula, 2 of them to use the square root method. Okay? Now, the question is, can all problems be solved with all methods? They cannot. So you need to be able to determine which ones will work with which methods. All right. So this is called a Frayer method, if you guys have ever heard that term before, which is where it's kind of broken into boxes for you. So the problem's in the center. And then we're going to look at solving that using all 3 of our methods. So what would be helpful to also have on your desk right now? Oh, it's definitely not pink. Orangish, salmon colored, whatever you want to call that paper. It's a fish. It's a word. It's a crayon. Look in your Crayola box. It's in there. All right. But guys, let's go ahead and pull that out because that should have your step-by-step, kind of all your methods kind of laid out for you if you filled it out as we went. So first thing on factoring. If I'm going to factor this, what do I have to do with the equation first? Set it equal to 0. So let's go ahead and do that. So it's 2x squared minus 15 equals 57. So we need to set it equal to 0 first with factoring. So we'll subtract the 57. So we get 2x squared minus 72. Okay, so we're thinking about factoring. What's the first thing you look for when you factor? GCF. In this case is 2. Okay, factor out of 2. We're left with x squared minus 36. What type of factoring is that? It's my favorite. You're right. It's my favorite. It's one of the easy ones, right? Difference of squares. How does that factor? X plus 6 and then x minus 6. He always puts that minus first. All right, that's your difference of squares. And then we need to solve. So we set each part equal to 0. Does baby brother give me an answer? No, there's no x there. So I don't care about baby brother. All right, so x plus 6 equals 0, x minus 6 equals 0. And then we have to solve each of these. So x equals negative 6. And x equals 6. How many answers should you get for every problem that you solve? You should have 2, because we're starting out with x squared. So every problem should have 2 answers. Okay, questions on factoring? Good. All right, square root method. If I'm using the square root method, what do I have to look for first to know if it can be used on that method? The bx. Does this have a bx? No. So can I use square root method? Yes. We want it to be missing it, right? So make yourself a note. This has to be missing the bx. Me too. All right, so it has to be missing the bx. It is, so it means we can use this method. Do I set it equal to 0? No, we isolate the x squared. So I'm just going to rewrite the problem. So if I want to isolate the x squared, what do I move first? 15. Add the 15. So 2x squared equals 72. Is it isolated? No, I have to divide by 2. X squared equals 36. Then what? Square root? Oh, I heard somebody say it. Plus or minus 6. Oh, I got the same thing I got when I fractured it. Mind blown, right? Will that always happen? It should. I have some, every year I have at least one student who's like, oh my gosh, like they didn't realize you could use more than one way to solve it. Okay? You know what's going to really make your mind be blown then? I can do it 3 ways. I can use a quadratic formula. Quadratic formula. Do I set it equal to 0 or no? Yes. Yes. So I'm going to go ahead and rewrite it. I already set it equal to 0 on the first part. So 2x squared minus 72 equals 0. And since there is no b value, when I plug it into the formula, I put a 0 in there. All right, so we get x equals negative b, so it's just going to be a 0, plus or minus square root b squared, so 0 squared, minus 4 times a, which is 2, c, which is negative 72, all over 2 times a, so times 2. All right, so then we clean up under the radical. So what is 0 squared minus 4 times 2 times negative 72? So x equals 0 plus or minus radical 576 over 4. Square root of 576 is 24. So 0 plus or minus 24 over 4. Do I need that 0? No. Adding, subtracting zeros kind of irrelevant. So plus or minus 24 divided by 4 is just plus or minus 6. Oh, I got the same answer. It would be very awkward if we didn't. Now, that being said, that I solved that problem, all 3 methods. Let's say you're on your test, and you went through and you used the method I asked for, and then you're like, I'm not sure if I did that right. Could you pick another method to check it? Yeah, you absolutely could. It's really bad luck if you get them both wrong and get the same wrong answer. Actually, real quick, before we move on, one other thing I want to talk about, because it's really easy to see if you can use square root method, right? It has to be missing the bx. If it's missing that, I know I can use it. Quadratic formula works on everything. How do you know if it factors? Because some of you struggle to kind of like figure out what those numbers to get them to work. Yeah. It does not have to have a GCF. No. But you know, there's something we can use. Go ahead and add this on your notes, guys. It's called the discriminant. Big fancy term, the discriminant. The discriminant is b squared minus 4ac. Where have we seen b squared minus 4ac? It's what's under the radical in the quadratic formula. Okay? If the discriminant, so if it is 0 or a positive perfect square, the problem is factorable. So if the discriminant is 0 or a positive perfect square, the problem is factorable. So if you are someone who's on that back page of the test and you're like, I have to factor 2 of these and I don't know which one's factor, you can actually find the discriminant and be able to tell if it will factor or not. Okay? Think about the discriminant. If you look at the problem we just did, the discriminant on this one ended up being 576. Is that a positive perfect square? Yeah, it was. The reason this works, if it's a perfect square, I can take the square root of it, the radical goes away, and we know if there's no I and there's no radical, then my original problem I could have factored. Okay, so if you're not sure, just do b squared minus 4ac. You don't even have to write it down. Just type it in your calculator quick, see what you get. If it's perfect square, then it'll factor. Okay, so it's a nice check to know if it'll factor or not. Does that make sense? Okay, comes in handy. All right, so if I look at the next problem, just for funsies, let's go ahead in this blank box down here. Let's find the discriminant. That way I can tell if it'll factor or not. So the discriminant again is b squared minus 4ac. It's already set equal to 0, so I know that I should be good. I don't have to move anything to find it. So b squared, so negative 4 squared minus 4 times my a, which is 1, my c, which is negative 45. What do you get for a discriminant? 196. Is 196 a positive perfect square? Yes. So since that is a positive perfect square, it means it'll factor. Why does it have to be positive perfect square? If I have a negative, good, you'd have an I, which means it's not factorable. All right, so back up to factoring. My discriminant's a positive perfect square. I know it's going to factor. Now, some of you may have looked at that problem and you can just tell it'll factor. Okay, but if you're somebody who's like, I don't know, and you're really bad at like guessing and checking those numbers, that's a great way to tell. All right, so factoring. So it's just x squared minus 4x minus 45. So is there a GCF? Nope, no GCF. So that means I set up my factors. Last one is negative, so my signs are opposite. One's plus, one's minus. Options for A, just x and x. Options for C, we can see it's 5 and 9. So positive 5, negative 9. Do you remember how to check these? All right, you can just check the inside outside if you need to. So that's 5x minus 9x, which is negative 4x. We make sure it worked. Okay, so you can check them if you need. And then we just got to solve. So this is where you set each one equal to 0. Again, if you can do this part in your head, by all means, you do not have to show your work here. So we will solve. X equals negative 5. Add 9. X equals positive 9. Can I use the square root method? Why not? It has a bx. It's got that 4x in there. All right, I can't do this because it has a bx. Can I use the quadratic formula? Yeah, I can always use any quadratic, anything that's x squared, you can use the quadratic formula. So x equals negative b. What's negative b? Good, positive 4. Plus or minus. You guys cool if I just write square root of 196? Because we found it right here. Lazy mathematician says I already did that work. I don't want to write it again. Over 2 times a. What's the square root of 196? 14. So x equals 4 plus or minus 14 over 2. Can I divide all 3 numbers? Yes. I can divide them all by 2. So I get 2 plus or minus 7. No I, no radical. Actually tell me the answer. So what's 2 plus 7? And 2 minus 7? Aren't we all shocked at those answers? Go right there. How are we doing? Now, what method on this problem is preferred? Would you rather factor it or use the quadratic formula? I'd rather factor, personally. Because factoring is easy. Like, for me personally, right, if I didn't rewrite the problem because it was already in the right order, I would have written it factored, and then I would have wrote my answers. I think some of you are at that point, too. Like, you don't have to show all this work in between. So, really, I would have, like, 2 lines of work. Be pretty quick and easy. All right. 2x squared plus 13x plus 21 equals 0. Right. Will it factor? Let's find out, right? Sometimes you look at it and you're like, I don't know, right? If you're not sure, let's check the discriminant. Right, so that's our b squared minus 4ac. So b squared, so 13 squared minus 4 times A times C. All right. What do you get when you find the discriminant? Nobody found the discriminant for me? Blue? 1? Is 1 a positive perfect square? Yes. When people freak out on that 1, what's the square root of 1? It's just 1. But side note, don't ever leave a radical 1 on your paper. It's really annoying. Okay, it's just 1. All right, so it will factor. So I'm just going to rewrite the problem up here. 2x squared plus 13x plus 21. Is there a GCF? No. All right, no GCF. My last one is positive, so my signs are the same. They are both positive. There's no negatives anywhere in there. Options for A? 1x and 2x. And then for C, we're going to have 1 and 21 or 3 and 7. Ruben, you got a preference? 1 and 21 or 3 and 7? 3 and 7? 3 and 7. Quick double check. I get 6x, positive 7x. That is 13x, so I know I factored it correct. Okay, so always check. Don't assume that you threw the numbers in correctly, okay? Make sure you check them. Even if it's just mentally and you don't write it down, at least look for that. All right, let me set each one equal to 0. And solve. So x equals negative 3. Subtract the 7. And then divide by 2. So we get negative 7 halves. How about the square root method? Why not? Oh, there's a B term. Bless you. Quadratic formula? Yeah, I can always use that one. All right, so x equals negative b, which is negative 13, plus or minus the square root of 1. We already did that math. Over 2 times a. Square root of 1? 1. Negative 13 plus or minus 1 over 4. Can I divide all three numbers? No. So am I done? No. There's no I, there's no radical, right? We want to keep going. This is where some students kind of struggle here. So let's just do the top first. What's negative 13 plus 1? Negative 12 over 4, which is negative 3. And then negative 13 minus 1 is negative 14 over 4, which is negative 7 over 2. Same answers I had over here. How we doing? You guys are real quiet. All right, last page, I want you guys to try on your own. Okay, determine whether or not it factors, if you can use the square root method, and then use the quadratic formula. Okay, so go ahead and take some time. Let's work through this. All right, first thing we want to do is determine if it factors or not. A couple of you jumped right in trying to factor and got real frustrated. How do you tell if it factors or not? The discriminant is what? A positive perfect square, right? So if we check the discriminant, right? You could, but is it necessary? It's not necessary. You know me, I'm a lazy mathematician. If I don't have to, I'm not going to. But you can. So discriminant b squared, it's going to give you 8 squared minus 4 times negative 2 times negative 20. You'll end up with the same answer whether you took it out or not. So what'd you get for discriminant? Negative 96. Is that a positive perfect square? It's not positive nor a perfect square. So this thing, that's not good. So that means factoring is a no-go. It will not factor no matter how hard you try. Right? Square root method? Nope. Has a bx. Quadratic formula? Yes, that one works. So x equals negative b, which is negative 8, plus or minus square root of negative 96 over 2 times negative 2. All right, so we need to clean up the radical. So we'll do our factor tree. It's going to be 3 and 32. All right, so x equals negative 8 plus or minus. Pair of 2's gives me 4i. Don't forget that negative was there. Radical 6 over negative 4. If your top's negative and your bottom's negative, what's that mean? It's actually positive, so I don't need those signs. Okay, and then can all three numbers be divided? Yep. Do I ever divide the number under the radical? No. But all of these can be divided by 4, so we get 2 plus or minus I radical 6. If you have the 1 there, it's fine. If you have it over 1, that's fine, just not necessary. How are we feeling? Good? All right. So let's kind of break down real quick. When I give you the test on Friday, and that back page has 6 problems on it, and I ask you to use each method twice, how do you know what to do? Where do you start? Okay, I can check the discriminant. Do I want to check the discriminant on all 6 of them? Which one is the easiest to recognize? Square root method. So the first thing I would do is I would use the square root method first. Why? Okay, good. Has to be missing the bx. So I would do that first. Because it's real easy. I can look through and be like, missing the bx, missing the bx. I'm going to do those 2. Okay? Because then I'm down to only 4 problems. Then now I need to find 2 of those that factor. Okay? So after I get those 2 done, I'm going to move on to factoring. And to know this, I'm going to check the discriminant. Right? So the b squared minus 4ac needs to be a positive perfect square. And then once I find 2 of those that will factor, I'm left with only 2 problems left, and I'll just use quadratic formula. Works on all of them. That makes sense? I'm trying to give you a plan of attack, how to know what method to use. For me, square root method is going to be the fastest because it's real quick. You're just getting a bite out, take square root, you're done. Okay, so that's always my go-to. If it's missing the bx, that's always what I'll do first. Okay, from there, factoring to me is faster than the quadratic formula. So I'd always factor, and then quadratic formula is there if I can't figure out anything else to do with it. Questions? Are we alive right now? You guys are quiet today.